Hello students, now I am going to bring to you in a speed shot about the various important topics and the derivations regarding the alternating current chapter. So it's a new series where I am going to focus in a very quick mannerism about the important topics. Most of the students have this idea that sir, please tell me the important topics, the most important topics in which I need to revise such that I am going to focus upon the important areas while I am in the last leg of the revision. So I brought that particular series for you on demand. This was on demand series I'm bringing up to you. And see, this is the first topic which I'm dealing with you over here is alternating current, and I'll be bringing the rest of the chapters also along with this particular series. So the first important topic in the AC is supposed to be the average current over the half and the full cycle. We do remember over the half cycle, it comes out to be for the sinusoidal as 2I0 upon pi, and the full cycle it becomes 0. That derivation. Then the next is RMS current over the half cycle and the full cycle. And we know over the half cycle and the full cycle the value comes out to be same. Next one. It is supposed to be for relation between RMS and the peak value. That IRMS is equal to I0 upon root 2. And also those kind of the question where AC is more dangerous than DC. Why? Then the form factor, right? The form factor of the sinusoidal AC. The next important is a principle of the hot wire instruments, the hot wire ammeter, the hot wire voltmeter, right? The heating effects of current is a principle behind that. And then the next one is the phasors for the pure R, in which V and I are in phase, pure L, in which we have the V leading the current by phase of pi by 2, and the pure C, in which the voltage lagging the current by the phase of pi by 2. So the phases for them. And the next one then, the impedance triangle, the famous impedance triangle, in which we have the reactance, the resistance, and the hypotenuse as the impedance, and it gives us the value for the phase also. The definitions of the reactance, the definition of the impedance, right? The reactance and the graphs of the capacitive and the inductive reactance, the one XL equal to omega L and XC equal to 1 upon omega C. One of them is supposed to be the linear graph and the second is supposed to be the rectangular hyperbola. The next one is supposed to be the phasors of the combination circuits for the RL, RC circuits, in which we have to check upon that what is the phase difference between the voltage and the current, right? So leading and lag behavior over there. Then the impedance reactance of the LCR circuit, right? Of the LCR complete circuit. And then the three cases of the LCR, that if it is supposed to be inductive circuit, then we have the voltage leading the current. If we are supposed to be having a capacitive circuit, then the current leading the voltage. And if it is the most important, that is the resonance conditions of the LCR CD circuit. The 3, 4, 5 most important conditions. We wrote 10 conditions. Most important 3, 4 conditions should be there, right? Next one. The next one is supposed to be the average power, which is there. VRMS, IRMS, cos phi, that particular derivation. The power factor of the cos phi, when it is maximum, when it is minimum. The wattless current, IRMS, sin phi, and the quality factor, which is also known as a voltage magnification factor, as a VL upon VR or VC upon VR, which terms out to be 1 upon R under root of L upon C. And the next one. The next is in the series is supposed to be the average power is done, power factor is done, wattless current is done, and the bandwidth. And what about it? That's a bandwidth. The bandwidth, the half power points, right? And then the important devices, 3 of them. The first one is a choke coil, which is used for minimizing the power losses. It's an effective LR circuit in which the R is kept low and the L is kept high. The next important device is a transformer, the most efficient device. We please focus on the principle behind that and also upon the idea of the losses inside the transformer, right? So the last device is supposed to be the AC generator. So the talk about the construction about it and the armature coil and the principle behind this, as the coil rotates and then it experiences the torque and all, right? And next is supposed to be the most important chunk, which you asked, what is the important most derivation? Ironically, in this chapter there are only supposed to be 3 important derivations, and over the years the CBSE have reduced the weightage of the derivations or the long derivations. Only the short derivations are surviving. So this is the first one, the impedance, reactance, and average power in the series. And this particular COVID pandemic, we are less likely to have the average power coming in, right? And the next one is supposed to be The next one is the relation between the peak and the RMS value, already told you beforehand, and the derivation for the resonance of the series LCR circuit. So these are the important derivation, not much, already covered in the topics. And the important graphs, graphs are very crucial for your revision. And the first of the important graphs in this is the reactance with the frequency, right? The XL graph and the XC graph. Then the VI graphs of the different combination circuits, LR, RC and LCR circuits, in which you show that who is leading the who, right? And then the impedance with the frequency, impedance Z graph with the frequency, when it gets minimum, when it gets maximum. It gets minimum at when? The resonance condition, right? And then the current response with the frequency, at the resonance it becomes maximum. So both side behavior of the resonance. And then important, the power graph with the frequency, the peak power, the half power, like that. Okay, so that's what it explains the bandwidth. Explaining the bandwidth in that at the low resistance what happens, high resistance what happens, and finally the sharpness of the resonance curve. So that's important topics in the alternating current. Hope so. This is going to benefit you, but you need to study whatsoever important. The topics are so many. The derivations are lesser than this. Do the numericals, all the numericals which we have done in the revision class. That's the NCERT class of the solving of the numericals. Do that and fare well in the paper, right? With this, I'm signing off. I will be bringing more videos of such kind in the upcoming videos for this, right? So for the time being, let me take a sign off from you. Happy learning. Bye.